Okay, so last time we studied about the vectors. Now let's begin the next topic, that is motion in a plane. Motion in a plane. Okay, so what's that? So for an example, suppose you have some object which is moving on a surface. Okay, or you can imagine if you throw a ball in space, it will move something like this. Okay, so if you take its trajectory, if you take its path, that path can be contained in a plane. Okay, its path, suppose it looks something like this. Okay, or it is any object which moves something like this. Then suppose this is the starting point of this object. Okay, so what we can do is basically any object is moving on a plane surface, what we can do is we can take its starting position, it is this one. To describe its starting position on the plane surface, what do we need? We need some point in reference to which we can measure its position, right? So that point we'll call it as an origin. Okay, this point is an origin. So this is our object at the beginning it is at this point, let's say A, and it moves like this. It moves on this 2D surface. So then we'll draw an x-axis and y-axis as per our convenience. Okay, so this is our x-axis, this is our y-axis, and then now if we draw a straight line starting from this origin to the position of that object, we call that straight line as position vector of the object. Okay, that straight line is known as what? The position vector of the object. Okay, so as the object moves on this plane, what will happen? Its position vector will change. So when it is here, its position vector will look like this. When the object is here, its position vector will look like this, so on and so forth, right? So now suppose this is the initial position vector, okay, at some time t, and in time delta t, suppose object moves from this point to this point. So what will be its position vector? Then its position vector is something like this. So object has displaced from this point to this point, and if you draw a straight line starting from the initial position to this position, okay, then this straight line is called as the displacement vector. Okay, this straight line is called as what? Displacement vector. And we can measure that displacement vector. How can we measure that? Using the triangle law of vectors addition, right? Okay, so what I can say is this is suppose the starting position vector, and the object, it moves from here to here like this. So this would be its displacement, right? This would be its displacement in time delta t. So this vector plus this vector is equal to this vector, right? Using triangle law we can say that. So this is, I am denoting this one as r of t plus delta t. Okay, this is position vector at time t plus delta t, and this is r of t, this is position vector at time t, right? So r of t plus delta t is equal to, I can say, this r of t plus the displacement vector, right? And therefore what will be the displacement vector? Just take that initial position vector on other side. So displacement vector is just final position vector minus the initial position vector. Okay, right? This thing is clear? Yes, no? All right, so this is displacement vector. Then what we can do is, so basically this whole idea of motion in a plane in space is that we can resolve this motion, and if it is motion in a plane, we can study it as two independent motions, one along x-axis, one along y-axis, right? So suppose this is your displacement vector. Okay, this one is your displacement vector, right? Delta r bar. Okay, what you can do is you can resolve it along two components, one along x-axis, you call it as delta rx, one along y-axis, you call it as delta ry, right? So this thing can be written as delta r bar is delta rx plus delta ry. Okay, delta rx bar plus delta ry bar, as we studied in the last lecture. Then now how can you write this delta rx bar? So we know that vector can be written as its magnitude multiplied by unit vector in that direction. So delta Rx bar can be written as delta Rx times I cap, and delta Ry bar can be written as delta Ry times j cap, right? I cap is unit vector in x direction, j cap is unit vector in y direction. Okay, then this is how we can write the displacement vector. We have resolved it along two components, one along x axis, one along y axis. So this is simple up to this point, and everything is going to be simple. Okay, there will be nothing difficult. So see, then how can you find out the average velocity? So you have displacement. If you just divide that by the time taken by the particle, okay, to go from initial to final position, so what do you get? You will get the velocity. So displacement vector divided by time will give you velocity vector. Okay, and then you put delta r bar is equal to this thing, delta rx into I cap, okay, plus delta ry into j cap. You put that here. So what do you get? Delta rx divided by delta t into I cap plus delta ry divided by delta t into j cap. And what is this thing? So you can just say this is the displacement along the x direction divided by time. So this is velocity in x direction. Similarly, what is this thing? This is the displacement along y direction. Okay, delta ry is displacement along the y direction. So delta ry divided by time is the velocity in y direction. So you get velocity is equal to vx into I cap plus vy into j cap. Okay, that's very simple, right? So the velocity can be written as what? Sum of velocities in x direction and velocity in y direction, right? Okay, total velocity or velocity of an object can be resolved into velocity in x direction plus velocity in y direction. Okay, and if we want its magnitude, how do we find the magnitude? So v just equal to, you can say magnitude of v bar, it's just equal to square root of vx square plus vy square. This is clear? Yes, no? Everyone? All right, very good. Then now this is the average velocity, and we know how to go from average to instantaneous velocity, how to find out the instantaneous velocity, right? So what is the instantaneous velocity? The velocity which is calculated in very small interval of time, right? That's the instantaneous velocity. So suppose v bar is the instantaneous velocity. By definition, it is what? Limit delta t tends to 0 of the velocity calculated in time interval delta t. And how do you find that? It is delta r bar divided by delta t. Okay, and again you can write delta r bar is equal to what? Delta rx divided by delta t into I cap plus delta ry upon delta t into j cap. And then what is this thing? So this is, you can say, it's derivative of rx with respect to time. Okay, this thing can be written as limit delta t tends to 0, delta rx by delta t is the derivative of rx with respect to t. Okay, so you can say it is drx by dt, right? Drx by dt. And what is this thing? So this is dry by dt, right? This thing is clear. What's the difference between this case and this case? So there we found the average velocity. Here what is vx? It is derivative of rx with respect to time. What is vy? It's derivative of ry with respect to time, right? So this thing can be written as, because we have limit delta t tends to 0, this thing is drx by dt multiplied by I cap plus dry by dt multiplied by j cap. Okay, this point is clear? Yes, no? Everyone? Okay, right. So this is just extension of the earlier topic that we saw. Okay, that is in motion in a straight line. When we want average velocity, we just take what? The displacement, total displacement divided by time. When we want instantaneous velocity, what do we need to do? We need to take derivative. Okay, all right. So then similarly we can find out the acceleration of the particle or of the object from time t to t plus delta t. So how do we find acceleration? So see, now here is the important point sorry, important point. So our object is moving like this along this path, right? So at the beginning here at point A, what's the direction of its velocity? So if you take very small displacement, if we consider, let's say, a displacement from here to here, okay, it will be along the path, right? So it is almost a straight line, and if we take very small time interval, then what do we get? Then to find out the displacement, okay, in time interval delta t tends to 0, what do we need to do? We need to draw tangent to the path. Okay, we'll need to draw what? Tangent to the path. So what's the direction of velocity at this point? If I want to say the direction of velocity at point A, then I will have to draw tangent to the path, because at this moment the particle is moving like this. Okay, then it's curving. Okay, its motion, its path is curving, but at this moment it's moving in this direction. Then after little bit of time it curves like this. So if you want to find out its velocity at this point, it will be moving in this direction, okay, for very little time. Then it keeps on curving. Okay, this thing is clear. So to find out velocity at a particular moment, what do we need to do? We need to draw tangent to the path, right? This is clear, everyone? Okay, so what will be the direction of instantaneous velocity? The direction of instantaneous velocity will be along the tangent to the path, right? What will be the direction of average velocity? So if you want to find out the direction of average velocity from this point to this point, it will be along this straight line. Okay, instantaneous velocity at this point and at this point would be different. The direction of average velocity between these 2 points will be directed like this. Okay, the direction will be like this. And if you want instantaneous velocity at this point, it will be along this tangent. At this point it will be along this tangent. Instantaneous velocity at this point will be along this tangent, right? Everyone, this is clear? Okay, so that's just difference between the direction of average velocity, instantaneous velocity. Okay, so then now suppose the particle moves from here to here. Okay, so suppose our particle moves from A to B in time delta t. So now we want to find out the change in velocity. So magnitude, suppose we know the magnitude, and suppose we know the direction. Okay, suppose we know the magnitude, direction will be what? Along the tangent. So at point A it's moving in this direction, let's say with 10 meters per second. Okay, at point B it's moving along this tangent, but here suppose it is some 15 meters per second, right? It can be same, the magnitude can be same or different, right? So suppose we know the magnitude. At point B it's suppose moving in this direction. So how much is change in velocity? So this is initial velocity vector whose size is this much. Okay, you take it, you draw it at point B. This is final velocity vector, means from A to B, motion from A to B. This is the final velocity vector. So what you do is you subtract this initial velocity from the final velocity, and then you get this thing, this much vector. Okay, the difference is this much, this is delta V, right? So this delta V bar is the change in velocity from point A to B. When object moves from A to B, this much is the change in velocity. Okay, and therefore now if you want to find out acceleration, what is acceleration? It is change in velocity divided by time. So if you want to find out the direction of acceleration, what will that be? Tell me, what will be the direction of acceleration? It will be in direction of change in velocity, right? Okay, so acceleration of this particle will be directed like this. Okay, so now see, what is the acceleration then? Acceleration is velocity at time t plus delta t minus velocity at time t divided by the time. Okay, and it is delta v bar divided by delta t, right? So then its direction will be like this, as we discussed. So this is the acceleration. Again, this acceleration can also be it can also be resolved in two directions. Okay, one along x-axis, one along y-axis. So a bar can also be written as ax into I cap plus ay into j cap. Okay, right? So everything, the displacement, the velocity, acceleration, we can resolve in two components, and we can study those two components separately, independently of each other. Okay, so if there is acceleration in y direction, that will not change the velocity in x direction. If there is acceleration in x direction, that will not change the velocity in y direction. This thing is clear, everyone? Right, very good. So now we have our kinematic equations of motion. So for example, you have s bar, it's equal to u bar into t plus half of a into t square, a bar into t square, right? So now if you think about the one dimensional motion, you don't say it is s bar or u bar, etc. But if object is moving in two dimensions, then you need to say that this is s bar is equal to u bar into t plus half of a bar into t square. Again, this equation can be broken into two equations. Which two equations? So if object is moving in two dimensions, you will say sx and sy are the displacements in two directions. If object is moving in space, then you can say that sx, sy, sz are displacement in three directions. Okay, and how can you write them? So just say that s is equal to ut plus half at square and put the appropriate suffix. Okay, so in x direction, what I will say is displacement in x direction is equal to initial velocity in x direction. Okay, it's ut, so u will be ux, okay, for x direction. So it is ux into t plus half of ax into t square. This is displacement in x direction, right? In y direction, it will become uy times t plus half of ay times t square, and in z direction it will become uz times t plus half of az times t square. Okay, and now if you want to find out the total displacement, what will that be? So total displacement s bar is equal to what? Sx into I cap plus sy into j cap plus sz into k cap. So this is in three dimensions. Okay, and if you want to find out its magnitude, what will be its magnitude? So the magnitude of s bar is equal to what? It is s, and that s is equal to square root of sx square plus sy square plus sz square. Okay, where does this come from? It comes from the resolution, right? Similarly, what is u? U is the magnitude of velocity, and that is equal to square root of ux square plus uy square plus uz square. And what is a? It's the magnitude of acceleration. It is square root of ax square plus ay square plus az square. So this is clear, everyone? Okay, so now let us solve some problems based upon these things. let's see this problem. The x and y coordinates of particle at any time are x is equal to 5t minus 2t square and y is equal to 10t respectively, where the x and y in meters and t is in seconds. The acceleration of particle at t equal to 2 seconds is. So now tell me, what should we do to find out this acceleration? Yes, this is simple, right? So now x coordinate is given, y coordinate is given. To find out velocity in x direction, what will I do? I will just say that it is dx by dt, change in x with respect to t, right? This is the displacement in x direction versus time, divided by time, you can say, but this is instantaneous velocity, okay, because we are taking derivative. So that's equal to d by dt of 5t minus 2t square and take its derivative, so you get velocity. So that is 5 minus derivative of 5 is 5, derivative of this minus 2t square, minus sign you can take outside, 2 you can take outside, derivative of t square is 2t, right? So this is 2 times 2t, that's minus 4t. So 5 minus 4t, this is velocity in x direction. What is the, this is velocity in x direction. What is the acceleration in x direction? So acceleration in x direction is equal to, let's call it ax. Ax is equal to dvx by dt, and that is just equal to d by dt of 5 minus 4t, take its derivative. So what do you get? You get derivative of 5 is 0 and minus 4 you can take outside, so minus 4 multiplied by dt by dt, dt by dt is 1, okay. So that is minus 4 meter per second square, but this is just acceleration in y direction, okay. Now sorry, this is just acceleration in x direction, and we want to find out total acceleration. That will be acceleration in x direction plus y direction. So now let's find out acceleration in y direction. What's that? So you have y is equal to 10t. So what will be vy? Vy is d by dt of y, right? So that is d by dt of 10t, and therefore, so if you take its derivative, what's that? It is 10 multiplied by dt by dt, so that is just 10, okay. And then you have acceleration in y direction. Ay is just equal to what? It is just equal to d by dt of vy, so dvy by dt, and vy is constant, that's why acceleration would be 0, so ay is 0. So what does that mean? What will be the net acceleration? Net acceleration is in x direction only, and its magnitude is 4 meter per second squared, okay. So it's option B, that's it, because acceleration in y direction is 0, right? Okay, good. So now can you solve this in little bit quicker time, little bit quickly? Can you solve? Anyone? Okay, so just remember, whenever you have a t square term, we saw this in last lecture, right? So you have x is equal to 5t minus 2t square. So there will be acceleration if there is at least t square term. Okay, then you have uniform acceleration. If you have t raised to 3 in the equation of displacement or position, you can say, if you have t raised to 3, then you will have time dependent acceleration. So here if you have t square term, then that means you have uniform acceleration. And what to do then? Then you have x equal to, or you can say sx equal to, okay, it is just equal to u times t, or you can say ux times t minus half of, let's say plus half of ax times t square. So if you just compare this, then what do you get? You get ux is equal to 5, and what is ax? Ax is equal to, or half of ax is equal to minus 2. That means ax is equal to minus 4, right? So you got ax. Okay, good. Then what about ay, acceleration in y direction? So this is y is just equal to 10 times t. So you can just compare this thing with what you can say, sy is equal to uy times t. Okay, and acceleration is 0 because there is no square term, no square time term in this equation, in the equation of displacement, or you can say the position, right? This thing is clear? Yes, no, right? So this is how you can quickly find out the acceleration. Okay, good. So then now you might say that this is the equation of displacement, this is equation of position. They are not at all different. See, how can I say that? So what is displacement in x direction? It is x minus x0. Okay, and if there is no x0, there is no constant term here, what does that mean? X0 is just equal to 0, right? X0 is just equal to 0. So where is this particle starting from? It is starting from origin, okay, at time t equal to 0, and you can find that also. So what will be x at t equal to 0 from this equation? From this equation, x at t equal to 0, put t equal to 0, you get 0, right? So x0 is just 0, y0 is just 0 if there is no constant term. This thing is clear, everyone? Okay, good. All right, let's see next one. So a particle is moving such that its position coordinates x and y are 2 meter, 3 meter at time t equal to 0, 6 meter, 7 meter at time t equal to 2 seconds, and 13 meter, 14 meters at time t equal to 5 seconds. Average velocity vector from t equal to 0 to t equal to 5 is, so at t equal to 0, these are the coordinates, at t equal to 5, these are the coordinates. So that means this is just extra information, you don't need to think about that, right? What are the coordinates at t equal to 2? Because you want average velocity, okay? So what is average velocity? You can say v bar is equal to vx into I cap plus vy into j cap, okay? So let's say starting position is x naught, y naught. So x naught is equal to what? At t equal to 0, x naught is 2 and y naught is 3. And at time t, x is equal to what? It is 13, y is equal to 14. Okay, so this is at t equal to 0 and this is at t equal to 5. Right? So what is Vx? It is x minus x naught divided by delta t, or you can say t minus t naught. And what is Vy? It is y minus y naught divided by t minus t naught, okay, into j cap. So that is equal to, this is 13 minus 2 divided by, it's going from 0 to 5, right? 0 seconds to 5 seconds. So time difference is 5. 5 minus 0 means 5. Okay, this thing into I cap plus y minus y naught. So 14 minus 3 divided by 5 into j cap. Okay, so this is 13 minus 2 is 11, 11 by 5. So 11 by 5 into I cap plus again 11 by 5 into j cap. So that is the answer, or 11 by 5 you can take common, so it's option D. Okay, so this is very simple question, right? They have just given one extra piece of information that we don't need to think about. So this is very simple. And then you don't need to write down this formula, then x minus x naught, y minus y naught. You can directly do this, right? You can always directly do this. Okay, so this is clear. Okay, good. This is very basic, right? Does anybody have any doubt in this? Indusha?
No, sir.
Okay,
Clear.
good. Very good. All right, let's see next then. A body is moving with velocity of 30 meters per second towards east. After 10 seconds, its velocity becomes 40 meters per second towards north. The average acceleration of body is, tell me, who will tell me this? Anybody? Body is moving towards east, 30 meters per second. And then, okay, let me ask this question. Body moves towards east, 30 meters per second is the velocity. Then it takes a turn and starts moving towards north, 30 meters per second. Okay, velocity, the magnitude of velocity does not change. Is there any acceleration? Is there any acceleration? Yes, there is an acceleration. Why? It's because of change in direction. Very good. Okay, so that's because of change in direction. Even if the velocity remains constant, direction changes, and that's why there will be acceleration. Okay, so velocity is a vector quantity. You can change velocity by changing its magnitude or its direction, right, or both. Okay, so here both are changing. So initially the body is moving towards east. So let's say that this is our east, west, north, south, and the body is moving towards east initially, like this. And then it starts moving towards north. Okay, like this. So the question is, what is the acceleration? Option C, root 7 meters per second square. Right. Okay, so this is 30 meters per second, or you can say this is v1 initial velocity, or you can say vy, or you can say u. Let's say u bar is equal to 30 meters per second. Okay, this is 40 meters per second. So this is v bar and this is u bar, right? So now you want to find out v bar minus u bar. What will you do? So u bar is directed like this, in this direction. Okay, so let me just draw it in this way. So let's say initial velocity is like this, it's directed like this. So this is my initial velocity vector. This is my u bar. Okay, so If I want to take minus u bar will be directed like this. Okay, and this is my v bar, 40 meters per second. This is my v bar, it's in north direction, this is in east direction, right? So this is minus u bar. Okay, this is minus u bar. I want v bar minus u bar, right? Because what is acceleration? V bar minus u bar divided by time. So we know, using the parallelogram law of vectors addition, this vector plus this vector, v bar plus minus u bar, that is v bar minus u bar, will be directed like this. This will be the resultant. Okay, or you can join it, you can complete the parallelogram. Like this, and then this will be your resultant, right? So what is this thing? This is my v bar minus u bar, v bar plus minus u bar, that is v bar minus u bar. How much is it? It's equal to, okay, this is the resultant. So magnitude of v bar minus u bar is just equal to what? Square root of u square plus v square. Okay, by parallelogram law, but it is just a rectangle. So that is equal to 30 square plus 40 square. So you can say this is 3 into 10 and this is 4 into 10. So 10 square you can take outside, right? So that is 30 square plus 40 square. 10 square you can take outside, square root of that will be 10, and multiplied by square root of, it's 3 square plus 4 square. So that is equal to 10 multiplied by square root of 3 square plus 4 square. 3 square plus 4 square is 9 plus 16, that's 25. So square root of 25 is 5. So v bar minus u bar is equal to, the magnitude of that is equal to 50, right? And therefore what is the acceleration? So acceleration is equal to, if I just want magnitude, it is just magnitude of v minus u. Okay, v bar minus u bar divided by time. So that is 50 divided by time is 10 seconds. Okay, so that is 5 meters per second square. So this is the answer. Right, so this thing is clear. Okay, so your answer was not correct, right, Yamini? What did you do? Solve this way or did something else? Same. Okay, no problem. Then some calculation mistake. All right. So see, this is how you will think about it. Okay, everyone, this is clear? Nikita, Selva Kumar?
Yes, sir.
Okay, good. All right, let's see next one. A particle starts from the origin 0 0, moves in straight line in xy plane. Its coordinates at latter time are √3 3. The path of the particle makes with the x-axis an angle of, tell me. Again, this is simple. It moves along a straight line. Okay, it starts from origin. Now I am explaining this, that's why I am drawing the diagrams and all. You will not do all of this. Okay, right? Okay, so particle starts from origin and it moves in a xy plane. So at latter time, you need to imagine all this in your mind, right, while solving. At some latter time, what are its coordinates? So x coordinate is √3 and y coordinate is 3. Okay, so this is suppose √3 and y coordinate is 3. Okay, so draw a straight line. So I can plot this point on the graph, and then this is just a straight line. This is starting point, and this is position at some later time, right? So this, its motion makes an angle theta with the x-axis. Okay, what will that be? So this angle theta is equal to, tell me. So you can always say tan of theta is equal to what? It is y2 minus y1 divided by x2 minus x1. Okay, it's option B. Let's check. So what is y2? y2 is y position at this time, that's 3. So that's 3 minus 0 divided by x2 is root 3, x1 is what? 0. Okay, so root 3 minus 0. So 3 by root 3. So tan of theta is root 3. So what's the angle? Tan of which angle is root 3?
60 degrees.
60 degrees, right? So it is option B, correct. Okay, so this is clear. Okay, so you don't need to draw the diagram. You will just say tan of theta is equal to y2 minus y1 divided by x2 minus x1, right? Tan of theta is equal to y2 minus y1 divided by x2 minus x1. Okay, so just remember the basics. All right, so from that you can solve it quickly. All right, let's see next one. A bus is moving on a straight road towards north with a uniform speed of 50 kilometers per hour. Okay, by the way, while solving the questions, while trying the numericals, you can draw the diagrams, okay, because it gives you some intuition about the problem. Okay, but then try to think in your mind only, right? Practice thinking in your mind only. So draw diagrams also now, but in final exam you can draw very quick diagrams, but don't be a Picasso. Right? Anyways, so this thing is clear. Yes, no? All right, good. Let's see next one. A bus is moving on a straight road towards north with a uniform speed of 50 kilometers per hour. Then it turns left through 90 degrees. Okay, a bus is moving on a straight road towards north with uniform speed of 50 kilometers per hour. Then it turns left through 90 degrees. If speed remains unchanged after turning, the increase in velocity of bus in the turning process is. Okay, so here sometimes students get confused. Now you will not get confused, right? Because you know that the velocity, there is change in velocity even if what? There is no change in the speed. That means speed remains constant but direction changes. Still there is change in velocity. Okay, so initially it is moving towards north by with a speed of 50 kilometers per hour. So like this it's moving initially. It is moving like this. Okay, and then it takes turn towards left. Okay, it takes turn towards left, right? Okay, so then what is the increment in velocity? Tell me. So this is final, this is initial, this is final velocity, this is initial velocity. What will be the change in velocity? Final minus initial, or let's take initial in this direction. The magnitude remains same. So this is initial, means this is u bar. So this is minus u bar and this is v bar. Okay, so what will be direction of v bar minus u bar? It will be directed like this. Okay, so if they ask us about the direction, then we'll need to draw diagram, right? All right, so this is v bar minus u bar. v bar minus u bar, and speed remains constant. So what will be its magnitude? So v bar minus u bar is the increment in velocity. So that is just equal to square root of v square plus u square. Okay, this side square plus this side square. So that is 50 square plus 50 square, or you can say 50 square times 2, and you want to take square root of that. So square root of 50, just 50 square is 50. Square root of root is square root of root 2 is how much? How much is it?
1.414.
Yeah, 1.414. Okay, so 50 times 1.4. Let's take 1.4 only. So how much is it? 14 5s are 70, right? 70 point something, 70.7 kilometers per hour. That's the answer. Okay, but this is magnitude, right? And yeah, they are asking about the direction also. Tell me what's the direction. This is east, west, north, south. What's the direction? Southwest.
Southwest.
Right, southwest. Okay, so it is option A. Right, so in this question diagram was necessary because they are asking about the direction. This is clear, everyone? Okay, good. Let's see next one. When an object is shot from bottom of a long smooth inclined plane kept at an angle of 60 degree with horizontal. Okay, so plane is kept at an angle of 60 degree. It can travel a distance x1 along the plane. Okay, but when the inclination is decreased to 30 degree and same object is shot with the same velocity, it can travel distance x2 distance. Then x1 is to x2 will be. Now you tell me. Okay, so let me explain this. So object is shot at an angle of 60 degree. Okay, so you have first plane which is inclined at an angle of 60 degree like this, and the other one is inclined at an angle of 30 degrees, right? So the object is shot like this up the plane, right? So in first case it travels a distance up to what? x1. So suppose it moves till here. So what will happen here? Its velocity will become 0. Okay. So now see, it's shot in this direction with speed u, you can say. So there will be some acceleration. That's acceleration due to gravity which is acting downwards. Okay. And there will be a component of that acceleration which will oppose this motion. Okay, so this angle is suppose theta. So acceleration due to gravity is acting downwards like this. So this is g. You can resolve it along two components, one along the motion and one perpendicular to motion, right? So one along the motion and perpendicular to motion. So let's do that. So see, I am resolving acceleration due to gravity in two directions. One will be along the motion and one perpendicular to motion. So this angle is theta. This angle will be what? It will be 90 minus theta. Right, this thing is clear. This angle will be 90 minus theta because this is 90 degrees. This is 90 minus theta. So again, this angle is 90 degrees. This is 90 minus theta. So what will this angle be? This is equal to theta. Okay, so this is equal to theta. So now can you tell me the two components, this component and this component, which one will be g cos theta, which one will be g sin theta? So if you remember what we covered in the last lecture, component along the plane would be g cos theta or g sin theta. All right. So see, okay, so you have any vector, suppose you have any vector and it makes some angle theta with x axis, this is y axis, and this vector is, you can say this is anything, this is vector a bar. So you can resolve this a bar along two components. What are those two components? So the component through the angle, yeah, along the theta, it's cos, yeah. So if you are going to this component, right, through the angle, then it is the cos component. If you are going towards the component starting from vector to go to the component, if you want to move away from angle, it is the sine component. Okay, so please remember this at least till this NEET. Okay, so component through the angle is cos component, component away from the angle is sine component. So this one would be a cos theta and this one would be a sine theta, right? Similarly, now if this angle is theta, then what will happen? Component through the angle, okay, component through the angle is cos component, so this one will be cos theta and this one will be a sine theta. So this is a cos theta and this is a sine theta. Okay, good. So we need to remember this, right, at least till the NEET exam. All right, so just resolve this along two components. So you have g component through the angle, this will be g cos theta this is g cos theta and that's g sin theta. Let me use a different color. This is g cos theta, okay, and this one is g sin theta. So this is g cos theta and this one is g sin theta. So what is component along the plane? It's g sin theta, right? It is g sin theta. So which component is opposing? See, the object is shot up the plane and the acceleration is down the plane, right? The component of gravity is down the plane, so it is opposing this motion. Okay, so finally the velocity becomes 0 when it goes till the top. Finally the velocity becomes 0. Then you have v square minus u square is equal to what? It's equal to 2as, okay, or you can say 2ax1, 2ax, let's say. So then what is this component? The acceleration is minus g. So this is 2 times of minus g into sine theta into x, that is v square minus u square. Okay, v is 0, at the top v is equal to 0 and therefore it is just u square is equal to 2g sine theta into x. Okay, u square is equal to 2g sine theta into x, right? So what's given here? So initially you take one plane which is inclined at an angle of 60 degree and object is shot from the bottom of that long smooth inclined plane. So it travels distance x1. Then in next case the inclination is decreased to 30 degrees. Okay, it's shot with the same velocity, same speed. Then it travels distance x2. So velocity is same, that means u1 is equal to u2. u1 is equal to u2, means what? 2g to sine theta 1 x1 should be equal to 2g sine theta 2 x2. Right? This thing is clear? Yes, no? Okay, good. So 2g gets cancelled out. So u is same, means 2g is anyway constant. Sine theta 1 x1 is equal to sine theta 2 x2. So what is x1 is to x2? We want x1 is to x2. Sine theta 1 x1 is equal to sine theta 2 x2, and therefore x1 is to x2 is just equal to sine theta 2 by sine theta 1. And now you can put the values, that is sine of 30 degrees divided by sine of 60 degrees. So that is 1 by root 3, right? Because sine 30 is 1 by 2, sine 60 is root 3 by 2. So that's 1 by root 3. Okay. So now this won't take any time. Now you just remember this thing. It will come in handy for this chapter, the next chapter, next to next chapter. What is next chapter and next to next? There is laws of motion, that is force, you can say, in that chapter also. Then there is work, energy and power. So inclined planes keep coming, okay, in these 3 chapters, and therefore you just remember this thing. If plane is inclined at an angle of theta with the x-axis, the component of gravitational acceleration along the plane is minus g sine theta, right? Component of acceleration is minus g sine theta. Okay, so it keeps on coming. So I guess there would be one problem at least based upon this thing, because it's there in 3 chapters. Okay, there will be definitely one problem on inclined plane. Almost every time there is. This is clear? Yes, no? Okay, good. So what's the answer? It's option D, 1 upon root 3. All right, let's see next one. A particle has initial velocity this one and acceleration this much. Speed after 10 seconds is. So just find out final velocity. So final velocity is equal to v bar is equal to, you can say, u bar plus a bar into t. Okay, but then yeah, so what is initial velocity? It is 3 I cap plus 4 j cap plus what is a bar? This is the a bar. Okay, so 0.4 I cap plus 0.3 j cap, and the time is 10 seconds. This is very simple question. Okay, so 3 I cap plus 4 j cap plus, so this is 10 times 0.4 is 4, so this becomes 4 I cap plus 0.3 times 10 is 3 j cap. So it is 3 plus 4 means 7 I cap plus 4 plus 3 means 7 j cap. So this is the final velocity. Yeah, option B, good. But they are not asking about the velocity, they are asking about the speed. So v is just equal to what? It is just equal to square root of vx square, you can say, plus vy square, that is the speed. That is 7 square plus 7 square means 7. You can say that this is 7, 2 times 7 square. So you can take 7 outside, so it's 7 root 2. Okay, and unit they have not given, so that means 7 root 2 units. That's the answer. This is very, very simple question. Okay, this thing is clear, right? Okay, so this is very simple question. So I don't expect, but I don't know. I mean, they can ask anything, because they have asked very, very simple questions, formula based questions also. All right, let's see next one. Two boys are standing at the ends A and B of a ground where AB is equal to A, small a, the boy at B starts running in the direction perpendicular to AB with velocity v1. Okay, so there is a playground and two boys are standing at the two ends of that playground. Okay, so this is a playground, let's say, and two boys are standing at two ends, A and B. These are two ends, right? This is line AB. The boy at B starts running in direction perpendicular to AB with velocity v1. So boy at B starts running like this, perpendicular to AB, they are saying, with velocity v1. And the boy at A starts running simultaneously. Okay, so he notices that his friend is moving like this. Okay, simultaneously he starts running and catches the other in time t, and he wants to catch him, okay, in time t. So he cannot run like this, right? He has to run something like this. Okay, so suppose he runs something like this, right? He runs something like this. This is the velocity of this guy. Okay, he runs with the velocity v and catches the other in time t. Now in order to catch the other one, so catch B, how much should be the y component of his velocity? So let's say this is the y direction, okay, and this one is x direction. How much should be the y component of his velocity? Tell me. v1, exactly, that should be equal to v1. Okay, otherwise he cannot catch, right? It should be equal to v1 because they are starting at the same time. So this guy covers some distance in y direction, that one will be equal to v1 times t. This guy covers some distance in this direction, but now in order to catch him, suppose he moves here, he also has to move here, right? Okay, he also has to move here. So then what will be the distance covered in x direction? It will be equal to the length of this ground AB. The distance covered in y direction must be equal to v1 times delta t. Okay, the distance covered in y direction will be same, right? So you can say that v is equal to, what is v? Velocity of A. Velocity of A is equal to what? Of A means boy at A. It is equal to v bar, that's vx into I cap plus vy into j cap. But A catches B, let's call them A and B only, but A catches B in some time t, and therefore vy must be equal to v1, that is the velocity at velocity of the boy at point B. Okay, so then we want to find out the time, that is the thing. Okay, so what will be the distance covered in x direction in that time? Distance covered is equal to this one, okay, length of the ground AB. AB is equal to A, right? So distance covered in x direction is equal to AB, that's equal to A, right? So therefore you can find out what is Vx. Okay, what is Vx from there? So distance covered in x direction, would be equal to what? This much AB. So that is equal to, I can say AB, which is equal to A, will be equal to Vx times t. Okay, and you want time, so that time will be equal to t is just equal to this distance covered, okay, AB, or they are calling the distance equal to a divided by Vx, velocity in x direction. Now can you find out this velocity in x direction? Because we want to find out the time. We know V bar is equal to this thing, right? So let me just add a page here. So V bar is equal to Vx into I cap plus Vy into j cap, and Vy is equal to V1, so V1 into j cap. Okay, so therefore V square, you can say it's equal to Vx square plus Vy square, that is V1 square, and from there you can say that Vx square is equal to V square minus V1 square, and Vx therefore is root of this thing, square root of V square minus V1 square, and therefore the time is equal to what? It is A upon Vx, that's equal to A divided by this thing, square root of V square minus V1 square. So this is the answer, A divided by square root of V square minus V1 square, or if you put everything in root, then it will be option D. Okay, this thing is clear. Yes, Selva Kumar.
Clear, sir.
Okay, good. Okay, so this one was a good problem because you need to think a little bit in this question. All right, let's see next one. Rain is falling vertically downwards with a velocity of 4 kilometers per hour. A man walks in rain with the velocity of 3 kilometers per hour. The raindrops will fall on the man with the velocity of, tell me. Okay, so see, raindrops will fall on the man with relative velocity, of the rain with respect to man. Okay, for an example, suppose you are just standing on ground and a bus comes from other side, okay, and the bus is moving with speed of 1 meters per second, let's say, or let's say 10 kilometers per hour. So what will be speed of bus for you? It is just 10 kilometers per hour. But now suppose you are also moving in the opposite direction, what will be the speed for you? Suppose you are moving in opposite direction with 5 kilometers per hour, okay, and bus is moving towards you. So actually both are moving closer to each other with the speed of what? Relative speed, right? That is the 15 kilometers per hour. No, it will be 15 because they are moving in opposite direction. So this is 10 and this is 5. So actually you need to take minus 5 here, because this velocity, if you take it positive, then this one would be negative, right? It is 10 minus minus 5, that's the relative velocity. So it is 15. Okay, so if you are also moving, then bus seems to be moving faster, right? It's like that. So here, if you are also moving, now you must have noticed this, that if you are standing in rain or you are sitting on your bike, okay, you are on your bike but you are just sitting and you are enjoying rain, so the speed seems slower, but if you start moving, then what happens? You feel that the rain is moving faster, okay, rain is coming faster to you and its direction will also change. Okay, its direction will also change. So see how. So see, rain is falling vertically downwards only, it's given. Rain is falling vertically downwards, okay, and with some speed 4 kilometers per hour. Man walks in the rain with the velocity of 3 kilometers per hour. So suppose man is walking in this direction, okay. So man is walking in this direction. So let's say man is walking like this, in this direction with a speed of 3 kilometers per hour. Rain is falling like this. Okay, so this is velocity of rain, this is velocity of man, and you want velocity of rain with respect to man. So Vrm, that is velocity of rain minus the velocity of man. So if this is Vm, velocity of man, what will be minus velocity of man? It will be directed like this. Okay, now if you are steady, you will see that the rain is falling vertically downwards. But now if you are moving in this direction, let's say in forward direction, then you will feel that the rain is falling like this. Okay, rain is coming towards you at some angle. You can find out that angle, right? So this will be the resultant velocity, or you can say effective velocity of rain for you. This is velocity of rain with respect to man, right? This is Vr, so this will be, this is Vm, okay. So this is minus Vm, and if you want to find out Vr bar minus Vm bar, then that is sum of Vr bar plus minus Vm bar. This thing is clear, everyone? Right, good. So therefore the velocity is directed like this, and therefore the rain seems to be coming at an angle, right? So what is the resultant velocity then? This is 3 and this is 4, so it's 5. Okay, so let me get rid of this man. All right, so Vrm is just equal to square root of Vr square plus Vr square plus Vm square. That is equal to square root of Vr square plus Vm square. 3 square plus 4 square, 4 square plus 3 square. Okay, that is 25. Square root of 25 is 5, and unit is kilometer per hour. Okay, so it is option D. This one is clear, everyone? Good. All right, then let's see next one. Rain is falling vertically downwards. Is that the same one? Yes, it's the same one. A man is walking due east at the rate of 2 kilometers per hour. The rain appears to him to come down vertically at the rate of 2 kilometers per hour. The actual velocity and direction of rainfall with the vertical respectively are. Okay, so now this is different. Man is moving in forward direction, let's say towards east, and the rain appears to him to come down vertically. So is the rain coming down vertically? It's not coming. Okay, it's not coming down, right? But not in vertical direction. So man is walking towards east like this. And what's the speed of man? 2 kilometers per hour. Speed of man is 2 kilometers per hour. 2 kilometers per hour. This is speed of man, let's say. Okay, and the resultant is like this. So what will be minus Vm? Minus Vm will be this one. this is minus Vm. I'm sorry, this is minus Vm, and this one is resultant. How much? It appears to him to come down vertically at the rate of 2 kilometers per hour. Okay, so for him, the rain comes down like this at 2 kilometers per hour. So this is effective velocity of rain, okay, for the man, right? This is velocity of rain with respect to man, velocity of rain with respect to man. This is not velocity of rain, okay? So how do we find the velocity of rain? We need to find out the vector. Oh, this one is shorter, I guess. So, okay. So see, if I complete parallelogram here, see, velocity of rain would be like this. Okay, this is VR bar. So the VR bar minus VM bar will give you what? VRM bar. Right? This thing is clear, everyone? Okay. This is VRM bar. So now you tell me what's the direction of this VR bar? How much is the magnitude, first of all? So option A, 2 root 2, 45 degrees. Yeah, that's correct. Okay, everyone? Right? So see, this much distance is what? It's 2. This is also 2, right? This is 2, this is 2, and you're drawing this. This is like a diagonal, you can say. Okay, if this is 2, this is 2, and this is also 2. Okay, so how much this distance will be equal to? This will be equal to 2 root 2. Okay, because this is a parallelogram, so this side and this side would be equal. So this is 2 and this is also 2. Okay, so if this is 2, then what you can say is, by Pythagoras theorem, this is 2 root 2, right? And then what will be this angle? So you can say that Vy, okay, or yeah, let's say Vy is 2, Vx is also 2. Okay, so this angle is equal to what? This is 45 degrees, right? Because tan of theta is, here it will be Vx divided by Vy. Okay, or here it is Vm divided by Vrm. Okay, so this angle is going to be equal to 45 degrees. So Vr, magnitude wise, it's equal to 2 root 2. Okay, by the Pythagoras theorem you can say. Okay, it's 2 root 2, and the direction theta is equal to what? 45 degrees with the vertical. Right, so this is simple. Okay, good. Let's see next one. A river is flowing from west to east with a speed of 5 minutes per meter. Okay, speed is, sorry, 5 meters per minute, not minutes per meter. 5 meters per minute. Okay, a river is flowing from west to east with the speed of 5 meters per minute. A man can swim in still water with velocity of 10 meters per minute. In which direction should the man swim so as to take the shortest possible path to go to the south? A river is flowing towards west. So river is flowing like this. Okay, river is flowing like this. Towards west. Okay, and west to east, sorry, yeah, so that's correct basically. So this is going from west to east. Okay, so then and speed is given, and man can swim in still water with the speed of 10 meters per minute. In which direction should the man swim so as to take the shortest possible path? Tell me. So velocity of river is given, velocity of the man in still water 10 meters per minute, it is given. Okay, so shortest path is simple, right? So everyone agrees that this is the shortest path. Okay, so velocity of the river is given, it's like this. Velocity of river is like this, right? It's too broad. This is velocity of the river. Okay, so tell me, what should be the velocity of man? Shortest path is this one, right? So if he comes along this path, what will the river do? If the man is steady, then the river will take him along with it, right? Okay, he will move along the river current. But if man is moving, so if man is moving in this direction, what will be the effective speed, effective direction of moving? It's his velocity plus the river's velocity. Okay, so he will move like this. But if he wants to move in this direction, so actually he should move at some angle. Okay, at some angle like this. Okay, so what should that angle be? So let's check. So this is 10, right? So this is 10, and this is velocity of man. This must be velocity of man in still water, and velocity of the, oh, I'm sorry. Okay, so this is velocity of man in still water plus the velocity of river should result in this velocity, right? It should result in this velocity. So what you can say is Vm square. Okay, we just want direction. Okay, so what will be this angle? So this angle is theta. So you can say sine of theta is just equal to what? Velocity of the river, because this is velocity of river, divided by velocity of man. So that is equal to 5 by 10. So therefore theta is equal to 30 degrees. Right, 5 by 10 means it's 1 by 2. Okay, so sine of theta is 1 by 2, means theta is equal to 30 degrees. So this is very simple. But then there are two 30s. One is east of south, 30 east of south, 30 west of south. Which one? This is the south direction. Option D, it is 30 west of south. Right, that's correct. So it's option D. Okay, this one is clear. Yes, no. Right, good. So there can be questions like this. All right, so this one is simple. A particle has initial velocity this much and acceleration of this much. So the magnitude of velocity after 10 seconds will be. So this is like a repeated question, right? So let's just skip this one. Let's see next one. A man is slipping on a frictionless inclined plane and back falls down from the same height. Then the velocity of both is related as. Tell me. Man is slipping on a frictionless inclined plane. Okay, so there is an inclined plane like this and man is slipping on this plane. Okay, and a bag falls from that height, from the same height. A bag falls. So what will be their velocities? Which one would be greater? Option A, velocity of B is greater than velocity of M. Why is it so? It's a frictionless plane. G cos theta is less than G. Yeah, that is true. G cos theta is less than G. But his acceleration would be equal to, acceleration along the plane would be equal to G sin theta. Okay. But here you can think of it this way. See, now it's not given that whether they cover equal distance, different distance. So this thing we need to take it for granted that they fall through same height. Okay, they fall through the same height. Right. So if they fall through same height, then now can you tell me the distance the velocities would be same or different? Yes, Yamini. The man is moving on the floor on this inclined plane, back just falls down. Okay, so the change in, yeah, it will be same. If they fall through the same height, then the velocities will be equal. So reason is just this thing. Okay, now we have not seen work energy and power, but I am just going to use a concept because I am sure you know about the potential energy and kinetic energy, right? So if the man and the bag, they are at some height, let's say h above the ground. Okay, so they are here, let's say. So the height changes, let's say by h, then what happens? Then what happens? The potential energy at this height gets converted to kinetic energy over here. Okay, initially the man is released, or we can say man starts sliding with 0 speed initially. Okay, right, this thing is clear? Yes, no? Okay, So initially he will have some potential energy, it gets converted to kinetic energy. That's it. Right? And that's why speed of man and speed of the bag will be same if they fall through the same height. Same height is given, that's why. Okay. All right. So this is also a simple question. Let's see next one. Speed of swimmer in still water is 20 meters per second. Now you answer me this one. Speed of river water is 10 meters per second and it's flowing due east. If he is standing on south bank and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to north is given by. Tell me. So our other swimmer was on north bank and wanted to go to the south bank. This one wants to move from south to north. Okay. The velocity of river is west to east, right? Flowing due east. So velocity of river is west to east and man wants to move from the south to north along the shortest path. Tell me what should be the angle? This is velocity of man. No, this is the effective velocity. So what does that mean? The effective velocity would be in this direction. It means that he will try to move like this due west. Okay, but how much? So that depends. So this is his velocity. This is velocity of man. Okay, this is Vm bar. And then you have velocity of river. It's like this. All right, velocity of river is like this, and the effect of 2 is such that he moves in this direction along the shortest path. Okay, so velocity of man is directed like this, velocity of river is like this. Okay, and this is the angle theta. So he swims some angle, let's say theta, okay, due west. West of what? West of north. Okay, how much is that angle? So sine theta, you can say it will be Vr divided by Vm, right? Sine theta here also it's Vr divided by Vm. That is velocity of river is 10 and velocity of man is 20. So again it's 1 by 2 only. Sine theta is 1 by 2 means theta is equal to 30 degrees. Okay, this one is clear? Yes, no?
Yes, sir.
Okay, all right. So in this kind of question we can make one shortcut, but now it depends what direction they are asking about, right? So you can say that if he moves along shortest path, then at what angle will he make his strokes? So it will be just sine theta will be just equal to velocity of river divided by velocity of man. Okay, this question is quite repeated. You can see this question is quite repeated. Okay, or maybe in different exams they have taken it. Sometimes it is rain, sometimes it's man swimming across the river. Okay, 1-2 questions I have not taken because it's the same question basically. Okay, so the width of river is 1 kilometer, the velocity of boat is 5 kilometers per hour. The boat covered the width of river in shortest time, 15 minutes. Then the velocity of river stream is, tell me. So now there is a boat. Okay, so there is a boat and width of river is given. Now width is 1 kilometers. Okay, so boat covers this width of river in 15 minutes, just 15 minutes. Then the velocity of river stream is, velocity of boat is given. So once again the velocity of boat will be directed like this. Okay, this is velocity of boat, right? Boat must be moving in this direction. Let's use this velocity of boat. Velocity of the river will be directed like this. Velocity of the river will be directed like this, and this is the shortest path along which, as a result of these two, right, boat wants to move in this direction, but river is taking it along the river current, and the result of these two is like this. It's moving in the shortest, along the shortest path. So if it can move in shortest time only if it is moving along the shortest path, right? So that is, what's that, 15 minutes. Okay, so here you can say VB square, what should we call this? Let's call this Vy. Okay, so VB square is just equal to VR square plus Vy square. Okay, but now do we know Vy? We want to find out velocity of the river. Do we know Vy? Yes, we know that it covers this much distance in what? It covers this much distance in 15 minutes. Okay, so Vy is just equal to distance covered, or you can say y divided by time. So 1 kilometer per 15 minutes, but we want it in kilometers per hour because the other velocity is in kilometers per hour to compare it. Okay, so you can just multiply this by 4, numerator and denominator. So then 15 minute times 4 is 1 hour. Okay, so it will be what? 4 kilometers per hour, right? So you got Vy also. So what will be Vr? So this is 5, this is 4. Then what is this? Yeah, 3 kilometers per hour. Okay, remember the right angle triangle 3, 4, 5. So there is a popular right angle triangle where the ratios of 3 sides is 3, 4, 5. So if this is 5, hypotenuse is 5, the other side is 4. That means this is equal to 3, right? Okay, anyways, if you remember, that's very good. Actually this is very simple. It also keeps on coming, right angle triangle. Okay, so 3, 4, 5, that is popular ratio. All right, so we want to find out Vr. So Vr will be just equal to square root of Vb square minus Vy square. Okay, so that is equal to square root of 5 square minus 4 square. Okay, so 25 minus 16, and that is 9, square root of that is 3. So that's why answer is 3. Right, that's very simple. Okay, and that's it. Okay, so these are the problems on motion in a plane. There were more problems too, but then you try some problems in the homework sheet that I will provide after the class, and let me know how many you can solve, right?